Welcome to The Explainer. Today, we're going to break down one of the absolute cornerstones of computer networking, subnet.
All right, let's just dive right in. Now, you might be thinking this sounds a little out there, a little abstract, but trust me, this one idea, it's literally the invisible engine that makes our entire modern internet work. It's the secret sauce that brings order to what would otherwise be, well, total chaos online.
You know, to really appreciate just how clever subnetting is, we've got to go back and look at the problem it was designed to solve. And that means taking a peek at the old, kind of clunky way that networks used to be built.
So, way back when, IP addresses were stuck in these super rigid categories. We called them classes. And what that meant was there was this fixed, unchangeable dividing line. One part of the address was for the entire network, and the other part was for a single computer or a host on that network. There was absolutely no wiggle room. Okay, this slide right here, it just perfectly lays out the problem. On the left, you've got this flat network. I want you to picture one enormous, super noisy room. Every single time one computer tries to say something, everybody else in the room has to stop and listen. It's a total nightmare to manage, right? But what companies actually need is what's on the right, a bunch of separate, much quieter rooms for each department. This is way better for security, and it just cuts down on all that noise, all that network congestion.
So the big question is, how do you get from that chaotic mess on the left to that nice organized setup on the right? Especially when you can't just go out and get a bunch of new IP addresses. Well, the answer, as you probably guessed, is the subnet.
And a subnet is pretty much exactly what it sounds like. It's a subnetwork. It's a clever way to take one big physical network and logically slice it up into smaller, isolated, and much more manageable chunks.
And this right here, this is the simple but brilliant trick at the heart of it all. See, we're not getting a new address. We're just looking at the one we already have differently. We borrow a few of those bits that were supposed to be for individual computers, and we use them to create this brand new middle section, the subnet ID.
But of course, this clever little trick creates a whole new problem. If that dividing line isn't fixed anymore, how in the world does your computer or a router know which part is the network, which part is the new subnet, and what's left over for the host itself? And that question leads us directly to the real hero of this whole story, the subnet mask.
The subnet mask is basically the secret decoder ring for your network. Think of it like a stencil. It's a 32-bit number, just like an IP address, and when a device lays this stencil over an IP address, it instantly shows which bits belong to the network and which bits belong to the host. It's what draws that new flexible line for us.
Now, the magic that makes this whole stencil idea work is a really simple piece of binary math called ANDing. And the rules couldn't be easier. If you have a 1 and a 1, you get a 1. Any other combination, a 1 and a 0 and a 0, you get a 0. That's it. That's the entire playbook.
Okay, let's actually watch this in action. First, we start with a device's IP address. Let's say it's 192.100.10.33. And underneath that number we all recognize is its raw form, a string of ones and zeros.
Next, we bring in our special subnet mask. Just look at the binary pattern here. All those ones on the left, think of them as the keepers. They're going to preserve the network part of the address. And the zeros on the right, they're the erasers. They're going to wipe out the host part.
And now we just do the AND operation, comparing the two numbers bit by bit. And what we're left with is a new address, 192.100.10.32. Now this is the important part. That's not the address of a computer anymore. That's the address of the entire subnet that our device belongs to. The mask did its job perfectly. It told us exactly which neighborhood this IP address lives in.
Okay, theory is great and all, but the best way to really get a feel for this stuff is to just build one from the ground up. So let's walk through a totally real-world example.
So here's our mission. We've been handed a single block of network addresses. Our job is to carve it up to create at least 6 separate private networks for different departments, sales, marketing, IT, all of them. Oh, and each of those new little networks needs to have enough room for at least 30 computers.
It all comes down to finding that perfect balance, that sweet spot. Just look at this table. If we only borrow 2 bits, we get 4 subnets, but we needed 6. So nope, that won't work. What if we borrow 4 bits? Well, now we have plenty of subnets, but we can only have 14 computers in each one, and we need 30, so that's out. But look at that middle row. 3 bits. That's the magic number. It gives us 8 subnets, more than enough, and it leaves us with 30 usable spots for devices. Why 30 and not 32? Because in every subnet you always lose 2 addresses, one for the network ID itself and one for the broadcast. So 30 is what we have left. Perfect.
And really, here's that whole decision process broken down into 3 easy steps. Step 1, we figure out that borrowing 3 bits is our best bet. Step 2, we calculate the new subnet mask that actually makes that happen. And step 3, we just double-check the math to make sure, yep, this new setup meets both of our original requirements. Done.
Now this idea, this concept of borrowing bits to create these flexible network boundaries, it was so effective, so powerful, that it completely changed the way the entire global internet is put together. It led to the system we all use today, classless inter-domain routing, or CIDR. It's classless because we threw out those old rigid Class A, B, and C rules. And that little slash with a number you always see after an IP address, that's just a CIDR shortcut. A /24 just means the subnet mask has 24 ones in a row. It is a super clean, super efficient way to describe any size of network, which is why it's the standard for the whole internet.
So subnetting is this amazing tool that lets us create these organized, efficient, and secure little network neighborhoods. But by making them separate, it raises one final, really important question. Once you've built all these nice, walled-off digital rooms, how do you let people in different rooms talk to each other? And answering that question, well, that takes us into the whole next layer of networking, routing.